Hello, welcome to the channel. We are continuing our integration series, and today we have an indefinite integral of x times sine square of x dx. A link to a playlist which contains all of the videos on this topic is in the description down below, and we may start solving our integral. Well, we see sine square of x, and we know that we can reduce its degree, right? There is an identity which contains cosine in it, so we can turn sine square of x into something that has cosine of 2x in it. Well, let me write the formula first. I'll make a brief remark here. Well, the identity itself is sine square of x is equal to 1 minus cosine of 2x over 2, right? Well, a brief note on how I remembered this back in time. I knew that there is a structure that cosine square of x or sine square of x, whatever, they are equal to 1 plus minus cosine of 2x over 2. And, well, cosine and cosine, they are pals, so there is a plus sign between them. And for sine square, the minus sign is left, right? Now, it may happen so that you don't remember this formula, although I recommend you to know this. There is another one, which is basically the same as this one, but its cosine of 2x is equal to cosine square of x minus sine square of x. This is a fundamental one, I would say. Formula of double angles, I think it's called. Well, now we want to express this in terms of sine square of x, since we want to isolate sinus only. And for this, we know that cosine square of x is 1 minus sine square of x, right? So it basically turns our cosine of 2x formula to 1 minus 2 times sine square of x, right? And, well, let me first also write that it's equivalent to 2 times cosine square of x minus 1, just in case, following the same logic, that sine square of x is actually 1 minus cosine square of x. Alright, now that we have these formulas for cosine of double angle, from this identity, we know that, what we know? That sine square of x is actually 1 minus cosine of 2x over 2. So this is what we needed in the first place, but it may happen so that you don't even remember the formula of cosine of 2x, but it's not a good story. You should keep that in mind, but it happens. You can write, instead of cosine 2x, cosine of x plus x, and since there is an identity for this as well, cosine of alpha plus beta, well, let's write plus minus, it's equal to cosine of alpha cosine of beta minus plus sine of alpha times sine of beta. Well, this, I would say, fundamental thing that you need to keep in mind, at least this, to do something in trigonometry. So following this, I can express cosine of 2x as cosine of x plus x, and write cosine of x minus sine of x, and this is the same as cosine square of x minus sine square of x. Alright, I think it's enough for a remark, and after this point the integral is pretty straightforward. We can just write this as integral of x times 1 minus cosine of 2x over 2, right, dx. Now, since 1 over 2 is a constant, we can put this out of an integral and write it as an integral of x, and meanwhile I multiplied this x with 1 minus cosine of 2x. It's x minus x times cosine of 2x dx. So we can split integrals now. We have 1 over 2 integral of x dx minus an integral of x times cosine of 2x dx. After this point, for some of you, the answer might be already known. Nevertheless, let's see what will be the final answer, since the integral of x dx is not a problem. It's x squared over 2. We have plus c, but since we also have another integral, I prefer adding some constant in the end. Minus, now for integral of x times cosine of 2x, we did in the videos before that when we see the structure of polynomial times trigonometric function, we know that these under differentiation they alternate with sine of 2x, like cosine and sine, while the polynomial may decrease its degree under differentiation. So we can just apply integration by parts here. We take x and cosine of 2x dx. So let me write it here. U is equal to, we take u as x, then du will be dx only, and we took dv as cosine of 2x dx, and v will be, in this case, it will be sine of 2x over 2. Right. Now, to not mix everything up, I suggest using parentheses here and writing with these. So we have x times sine of 2x over 2 minus an integral of dx times sine of 2x over 2, sine of 2x over 2 times dx. Alright, now let's move and slightly open up brackets. For this expression we have x squared over 4 minus x times sine of 2x over 4 and plus, I believe, well, we have 1 over 2 from this place, and there is also 1 over 2 here. Since 1 over 2 is a constant, we can just neglect it inside the integral and put it outside. So we have 1 over 4 times integral. 1 over 4 times integral of sine of 2x dx. And finally we have our result. It's x squared over 4 minus x times sine of 2x over 4 plus, now antiderivative of sine of 2x is cosine of 2x over 2, and we have minus here, right? Like its derivative will be sine of 2x over 2 times 2, since we have 2x here, so we have sine of 2x. It was a quick check. Therefore, keeping in mind that 2 that we obtained here, we can directly write 1 over 8 times, or even better, we can write just sine of 2x over 8 and add some constant. So let's quickly check if we did it right. We had this, which turned into this. Okay, then we had this, which turned into x times sine of 2x over 4. And we had 1 over 2 times minus plus integral of sine of 2x dx over 4. Yeah, that's also right. Wait, yeah, I said that we have like integral of sine of 2x will be minus cosine, but I didn't write it here, right? Sines alternate. Like derivative of cosine is minus sinus, so we should have minus here. Now it seems to be clear, I think. Yes, it is. Yeah, it's our final answer. I'll just rectangle it as I always do. If you have some questions, feel free to write them in the comment section below for this video or for other ones. And see you on the next ones. Bye.